Now we're going to look at continuity and differentiability. These two concepts are very closely linked in calculus. First thing I want you to do is go to your notebook, all right, and answer the following two questions. I don't want you to use complete sentences. I know, hard to believe. It's not English, but that's okay. And answer why you believe. Okay, does continuity imply differentiability? And does differentiability imply continuity? Okay, stop the video. When you're done, restart it. Now, to discuss differentiability and continuity, sometimes it's easier to go to another form of the derivative. Another form of the derivative is to find f prime at c is equal to the limit as x approaches c of f of x minus f of c divided by x minus c, where here I've got some curve and I'm looking at my point here. Okay, and we're looking what happens as x gets closer and closer to c. All right, from either the right or the left, it doesn't matter. Now, what this means is both the right and left limits must exist and they must equal. So the limit as x approaches c negative is f of x minus f of c divided by x minus c. And this has to equal the limit as x approaches c f of x minus f of c divided by x minus c. So both the right and left-hand limits have to be equal. They have to exist and they have to be equal. So let's look at this one right here. F of x is x squared minus 5. Nice parabola. We know it's continuous. Let's use this definition to find the derivative. All right, so let's look at the limit as x approaches c of f of x minus f of c divided by x minus c. Let's pick x equal, what do you want to pick, guys? Can we pick 0? Let's look at c equals 0. So the limit as x goes to 0 of x squared minus 5 minus f of c is 0 squared minus 5 divided by x minus 0. So this becomes the limit as x approaches c negative. Let's see, those are going to cancel. That is 0 of x squared over x, which is the limit as x approaches c negative of x, which is just c. Turns out it didn't matter whether we came from the right or the left. Did I do that right? It looks like it. All right. Now it turns out that a function f is differentiable on the closed interval ab if it's differentiable on the open interval and the derivative from the right and the derivative from the left both exist. Let's look at this function right here. On the interval, let's go -1 to 1. That's going to be our interval. Let's use our definition and find the limit as x approaches 0. So the limit as x approaches 0 of f of x minus f of 0 divided by x minus 0 is equal to the limit as x approaches 0 of x to the 1/3 minus 0 divided by, let's just call it x. So this is the limit as x goes to 0 of x to the minus 2/3. And we see this becomes infinite. So what does that mean? This function right here is continuous over the closed interval, but it is not differentiable at x equal to 0. If you were to graph this, what you see is it comes in fairly flat, but it becomes basically vertical when you get close to the origin. So the slope becomes undefined. So in this example, f of x is not differentiable at x equals 0, but it is anywhere else. So the function's continuous, but not differentiable. What about this function? F of x is x plus 4. Let's look at what happens as, let's say, x approaches negative 4. So the limit as x goes to negative 4. And for this one, let's look at it going negative there. Let's see, this is going to be f of x minus f of negative 4 divided by x minus a negative 4 is plus 4. All right, so the limit as x approaches negative 4 minus is, let's see, what is this? It's the absolute value of x plus 4 minus, now f evaluated at negative 4 is 0 divided by x plus 4. Now let's look at this. This number is, what does this look like? Let's look at the graph. All right, it's the absolute value of x plus 4. So when x is negative 4, here's negative 4, it's actually 0. And when x is 0, it's up here at 4, so it does something like this. All right, so now as it's approaching negative 4, from the negative sign, the slope is actually negative 1. And let's do the limit going from the positive side. The limit as x approaches negative 4 from the right is the absolute value of x plus 4 minus 0 divided by x plus 4. In this case, the slope is plus 1. So in this case, the function's continuous, but it has this sharp point here. The left limit does not equal the right limit. So you can write it like this. The limit as x approaches negative 4 negative does not equal the limit as x approaches negative 4 positive. So f prime of negative 4 does not exist. Now, here's the theorem. Got to pull things together. If f is differentiable at c, then it's continuous at c. Do you notice it doesn't say the converse? Continuity does not guarantee differentiability. Differentiability guarantees continuity. Now, why don't you try some problems? Stop the video, and when you're done, finish your homework.